In this video, we're going to be creating two tools that will allow us to quickly design our levels. The first will be our level spawner. And as you can see from here, I can click on, if I center this, you can see that I can procedurally generate a road, and I can do so by hitting Alt and clicking one of these dots. We see our road procedurally generated. And from here, I can also adjust the length to smooth it out. There you go. And the next tool is our BP underscore pickup coin. So this essentially just spawns our pickup coins. So I can center this, have it spawn here. And by dragging this spline, I can create more coins. And I can also adjust how many coins by modifying the spacing. So a smaller spacing means more coins will be spawned. So once I do that, what I can then do is get my character and drag him into the level, and then from there, and from here, I can get a jump pad and play the level. So we have our coins. I can pick them up. And then we reach the end of the level. And as you can see in here, these were the assets that I used to create my level spawner. So it essentially chooses which asset to pick based off at what index in the for loop it's at currently. So these meshes were designed in Blender, and I'll leave a link to that in the top of this video. So with that being said, let's get to it. Okay, so starting from where we last left off, I'm going to go into Files, and then I'm going to click on New Level, and then I'm just going to make a default. So from there, I'll just get rid of this and just save that. And I'm going to be saving this in our new folder, or in our levels folder, and I'm going to be calling this level 2. I'm going to select the levels folder just to make sure that that's the directory to install it in. And once I've done that, I'm going to be making a new folder, and this new folder will be called spawning. Spawning system. And I'm going to be having this in the content. There we go. So we have our spawning system. So in here, this is where I'm going to be creating our BP level spawner. So let's go through that. So I right click, blueprint class, let's make that an actor, and then call this BP underscore level spawner. So in here, I'm going to be clicking on that. Since this is a visual actor, since we're just using it to create the level, we have no need to start with a tick. So to save performance, we're gonna disable that. And we're gonna compile and save that. Okay, so from here, I'm going to my construction script. And what I'm going to do is I'm going to have a for loop. For loop. So keep executing this command for as long as this condition is met. So if I were to say 10 as the last index, and then have a print string in here, then the print string will be executed 10 times. I'll print the index. So compile and save that. You'll notice if I drag the actor, it prints out every time I move the actor. So any change in transformation to the actor will cause the construction script to run again. So we'll notice every time there's a change in the actor, it will loop and print the numbers 1 through 10 or 0 through 10 each time the actor is moved. So going back into our for loop, this is the important part. We want to determine how many times we should loop to create our road. So we know that our road contains 3 pieces. It contains a start piece, it contains a middle piece, and it contains an end piece. We know for a fact that that our start road should print out the first piece of the road, the start road, on its first iteration, and print out the end piece of the road as its last iteration. So how do we know how many times we should iterate to spawn these meshes? So if we go into our BP, or if we go into our spawning system, for our spawning system, we're going to need a spline component. And this spline component is a tool we're using to modify our mesh. So if I were to click on one of these, we notice that we can modify the length of the spline by hitting Alt and then left clicking. And we can do that on and on and on. And that's how I was able to spawn the level as, spawn the road as was shown in the demo. So that's what the spline component is for. So I'm going to undo that. How do we know what the last index for this spawning system is? So if we take a look at how division works, we have our spline, which is, let's say, 800 units. And we have each mesh, let's say each mesh is around 200 units. So how many times should our for loop run in total to spawn each mesh, which is of size 200 units, in a spline length of 1800 units? So all we would have to do to figure this out is take our total length, which is 1800 units, and divide it by the length of each spline, which is 200 units. And by doing so, we know the exact number of iterations needed to spawn each tree. So dividing them will tell us the number that we need, the number of times we have to loop in order for us to fill out this spline length with each individual mesh, all of length 200 units. So all this means is we need 90 meshes to fill this length to the brim. 90 of these in order to fill this up. If each mesh individually is 200 units, we would need 90 of them in order to fully occupy the spline length that we've created, which is 1800 units. If the spline length was maybe 2600 units, note that the spline length is something that gets varied, and it gets easily varied just by taking the length of our spline in the viewport and just clicking on one of the endpoints and hitting Alt. Just by doing this, I'm adjusting the length of my spline. So the longer it is, the more meshes we can put in, which means the more number of iterations we're going to be going through. The key concept is that we want to know how many meshes to spawn, and we do so by taking the length of the whole section, or the whole spline length, and dividing it by the length of each section. Now, for this example, I gave it the length. For this example, I gave the length of each section to be 200. But if we were to go into our level, we'll notice that the length of each start mesh is approximately 600 by 600. So if we were to go into our spawning system and go into our construction script, so the first index is 0, that's fine. But the last index will be determined by taking the length of our spline, and we can do so by Control and left clicking. And from there, drag this node out and then say get length, get spline length. So we have our spline length, which again in this example was 1800 units. And what we did is we got the length of each spline section. Now remember that the length of each spline that we created is 600 units. So I'm going to be creating a float. So in the variable section, I'm going to be creating a float. And I'm going to be naming this road block length. So from there, I'm going to be taking this boolean and then converting it to a float. Okay, so I'm going to make this public, and I can do so by just left clicking in here. So I can fine tune this in the view editor. So I'm going to be saying this is 600, which is the length of each spline section. So if I were to control and right click this, from here I know I'm going to need a division. So I'm going to do float divide by float. And put this in there. And after that, all I would need to do is insert this for the last index. But when I do so, you'll notice that it says truncate. And the reason it truncates the values, the reason it does so is because the indices for a for loop have to be integers and not float values. So what we're doing by truncating it is just turning it into an integer. So in this example, -1.6 becomes -1, and 1.6 becomes 1. The only reason we're doing that is because we have the indices for a for loop are treated as integers and have to be treated as integers. So always never forget that the indices for a for loop have to be integers. So in our loop body, this is the code that's going to be executed each iteration. So in each iteration, I'm going to be adding a mesh to our spline. And I can do so by saying add spline mesh component. There's also another function called, or there's also another node called add static mesh component. And we won't be using that. And the reason we won't be using that is because our add spline mesh component contains a function inside of it called start and end node. And this will allow us to morph the shape of our static meshes that we designed in Blender in order for it to have these upward slopes and downward slopes. So we have our target. So what I can do from here is just connect that to the add spline mesh component. And what I need to figure out is the start position, the start tangent, the end position, and the end tangent. And to do so, all I would need to get is the spline itself. And from the spline, what I can do is left click and drag and say get location at distance along spline. Now, to determine what distance our spline should be spawning for this start position, we need to know exactly what iteration our spline is in. And for that, we need to know the index of our spline. So what I'm going to do is I'm going to right click and promote this to a variable, our index, and just connect it so that it connects to our add spline mesh component there. And I'll just rename this the index. Okay, so our distance is determined by our current index multiplied by our road block length. So it's going to be int times float. And if I were to get my road block length and take that, so it's the index multiplied by the road block length. And remember, the road block length is just a fixed value of 600. So what this means is that we're spawning an actor on the first iteration. We're spawning an actor, and the distance is going to be, on the first one will be the index, which is going to be 0. multiplied by our roadblock length, which is 600. And this just amounts to it being 0. So if I take this in here, so that's our start position. And for our start tangent, all we need to do is the exact same thing. So I'm going to be copying this and getting our spline. So I'm gonna control, left click, and instead of getting the location, I'm going to be getting, instead of getting the location, as you can see here, we want the tangent. So I'm going to take our spline and say get tangent. Get tangent at distance along spline. So from there, I can just put that into the distance, and I can just plug that value in for our tangent. So for the end position, that's just going to be the position on the second iteration. So on the first iteration, everything is zeroed out because the index is 0. But on the second iteration, when the index is 1 multiplied by our roadblock, which is 600, that's just going to be 600. So our end position will be 600. So if I were just to copy this, just copy this whole thing and paste it in here. So exact same logic, but instead of just plugging in the index, I'm going to say int plus int. So we have integer plus integer. And in here is how much we're adding it by. So I'm choosing to add it by 1. And the same thing goes for here. So integer plus integer, I'm choosing to add it by 1, and I just drag that in here. So this represents our current index. So if I can left click and then hit C to make a comment, and I would say this is our current index. And then this would be our next index. Next index. Okay? So we take our start and end and just drag our end position and get our end tangent. There we go. And from here, what I can do, so now that I've created this spline mesh and then spawned it in the right location, all I would have to do is determine what spline gets selected. And to do that, all I would have to say is set static mesh. So in here, where I'm adding the spline, I want to define what spline gets added. Yeah, I can define that by saying set static mesh. And this is just determining which block it should pick. So now that we have our static mesh, this new mesh is going to be the thing that it renders in this screen. So if I were to just click on that and then left click, drag out, and then say select node, what it will do from here is it will create a select node. I can have sm underscore start road. So choose this sm underscore start road, and then I can make this a boolean. So if the index, so I can drag my index, which was coming from my for loop, and I can say if it's equal to, if it's equal to 0, which it will be in the first iteration. So if that's the case, then select our start road to be the mesh that it renders. Otherwise, we can select our straight road. But one thing we can do though is even make another select node, because we can create another select node. And the reason we're doing so is just to determine if we reached our last iteration. So this select node in here, so if it's true, then if the index is 0, then just pick the start node. Otherwise, if the index is the last index, so how do we get the last index? It was just the length of the spline. So again, we just took the length of our spline, which was whatever length it is, divided by the length of each section. So just gonna do that. So right click, get our length, and get spline length. And divide it by each roadblock section to know how many iterations it should go through. So if we drag this and we said so if our index, when our index reaches the very last iteration, it will be equal to this value. So what I can do is truncate this, because this will give a float value. So I can truncate it. And if that truncation is equal to our index, because our index is going to be integer values, so it wouldn't make much sense to compare an integer to a float. So we need to truncate our float value so it can match the integer. And now from here, I can say equal, and I'll just alt click and do, if the index is the last iteration, then you will be equal to the length divided by the road section. So if that is the case, then we'll know that in that situation we need to spawn our end block or end road. And otherwise, we're gonna need to spawn our straight road. There we go. So from here, we're spawning our end road or our straight road, depending on what current indexes it's at. I'm gonna be connecting this set static mesh to this add spline mesh. What I'm also gonna do is set the collisions, because by default there will be no collisions, and we can set the collisions by dragging this and say set collision query. Set collision enabled, and our target will be the spline mesh component. So I can click on this to add a reroute node, and from there I can move it around a bit. And just drag that in here. So this is our spline mesh component. It's being set in the static mesh, and we're also using that for our collisions. We're also using that for our start and end position. So this return value is being used in the set static mesh. It's being used in the set collision enabled. It's being used to set start and end. This is for morphing our shape. And we're also going to be using it for setting the forward axis. And this is not necessary, but it will make it so that the design of the spawning system will be able to work with a mesh regardless of what its forward axis is. So right now it's set to X, and if you remember from the Blender video, we set our forward axis to X. But in a situation where some designers set their forward axis to Y, so for example, if you're dealing with pipes, typically its forward axis will be its Z. So from there we can just pick Z to be the forward axis. So it just makes it so that it's slightly more accommodating for different types of static meshes that are in the marketplace. Set static mesh, set collision, and then set forward access, and that connects to our set end. And in our set end, we have our current index, which is our location at the spline, and our tangent. And our next index will be the same thing, just added 1 to it. The way we were selecting our nodes, so that in the static mesh, the way we were able to define what nodes to select or what static meshes to render is we looked at the index. If it's 0, we want the start node. If it's not, then check if it's the last index, and we're able to do that just like how we were able to determine the last index in our for loop. In here, we got the length of our spline, so we got the length of our spline, and then we divided by each section, and that gave us the total number of iterations we need to go through to render our, to create our procedural road, or how many static meshes we should be spawning in this spline length. So that's just a quick overview of the whole system that we created. So now we can test it out. So if I were to click on this, so get our spawning system. So we have our road, and I can alt and then left click to create a road. I'm going to hover a bit and click on the node in here. So where my cursor's at, left click, and then alt to drag that. And we have our start road. And we can modify each point, and based off how we modify it, we notice that the section length, or we notice that the way that the static meshes get spawned is slightly different. So I can smooth it out to increase the length of each spawn. So I can make this around 800. I can make this around 800. And yeah, and I can also morph the shape, and can morph the shape. So we can get that there. And have the section maybe 1200. Yeah, and that's how we spawned our level. And then we can, just to test it out, take our ball character, put him into that level. So let's play it. Oop. So it didn't seem like it rendered the collisions. And it's probably because in our set collisions, I forgot to put collisions enabled query in physics. Yeah, so if I compile that, now if we play the level again, we notice now it blocks it. We have our ball, and it's able to spawn in the level that we just created, which is great. Okay, so now we're going to be creating our pickup system. So the way we're going to be doing this is we're going to create a blueprint class, and we're going to name this BP pickup spawner. And this is what we're using to spawn our coins. One thing we would want to do before we create our spawning system is to make sure in the event in our casting, instead of us just taking the cast and just putting it into the get actor location, what we can instead do is store this as a reference. So if I left click on this and then say promote to variable, and I'm just going to name this ball underscore reference. So I'm just doing this so that it doesn't have to cast every time it needs information about the ball. So in this case, in our delegate, so in this case, we used the ball to get we needed its location. So instead of just casting each time we need its location, we can save some performance. We can save a performance issue, and just store a reference every time once we cast, so that we can just use that reference. So in here, I can get our ball actor, and then from there, I can say get actor location. And that would mean we wouldn't need this guy here. So we can just use our ball reference and then just place it in there. So from there, we have our cast, we stored our reference, and can save that. Yeah. So now going back to our spawning system. In our spawning system, all we would need is our begin play. So we wouldn't need anything else, which means, so if I were to compile this, which means if we go under the class defaults, I wouldn't need to start with tick enabled to just save some performance. So in our begin play, I'm going to be writing a for loop, and this for loop is the exact same for loop that we've used for our level spawner. So what we did in our level spawner is we took the length of the spline and then we divided it and took the truncation and have that as our last index. So that's what I'm going to do in here. I'm going to be creating a spline just like I did for my procedural road. So spline, and click on that and then make that the root by left clicking and then dragging as the default scene root, and control, left click, and get spline length. And from there, say float, divide by float. And the next float I'm doing is I'm going to create a variable and I'm going to call this spacing instead of length of each roadblock. This spacing will determine how many iterations we want to go through. So we're not really morphing the shape of our coin. We just want to know how many coins we should spawn. And we can do so by just defining how much spaces should be between each coin. So the more number of spaces, so the higher the number of spaces, the less number of coins will exist in our spline. So in here, if I compile this, notice if I have 400 as a spacing, then it's going to be the length of our spline divided by 400. So we're going to truncate that. And then we're going to be placing that as our last index. So just a quick example of how this would work before we write the code. So how many coins can we fit in this spline length, which is 800,000, which is 80,000, which is really not to scale, is we just take the total length and divide it by the length of each space. And that would be, the zeros cancel out. So 80 divided by 4, and that's just 20. But I said 4,000, it was really 400. So then that would mean there's 200 coins being spawned into this 80,000 unit spline length. Yeah. So we notice that the larger this number gets, the larger this spacing gets, the smaller this number will be. So if this was like 800, so as an example, if we took our 80,000 and we decide our spacing should be 800, that would just mean that the number of coins that will be spawned, so the zeros will cancel out, and we'll just have 100, which is half the number of coins we got when the spacing was 400. Yeah, so going back into our code, our loop body, it's a simple function that we're going to be using. So all we would need in our loop body is spawn actor from class. So in here, the class we're choosing is going to be BP underscore pickup. So I have to make sure that it's going to be a blueprint pickup and not a C++. So I'm just going to be checking the name. Okay, so the blueprint version is called BP underscore pickup coin. So I'm going back into that and selecting BP underscore pickup coin. So from there, I need information about the spawn transform, which is basically where the coin will be spawned in the world. So I can split this to a struct just so I can see it out. So I need the location and the rotation of the coin. So the way I can get the location and the rotation is through the spline itself. I can say get location along a distance along spline, and the distance will be specific to that coin. And the way we are able to do that is we're going to promote our index because each spline or each coin will vary based off what index it's in. So if I were to take my index, and from there, I'm going to say times float. And it's going to be the spacing. So we have the spacing in here, and we can plug that as our distance. And we can put that as a spawn location transform. And we want to make this relative to the world. So instead of saying local, we're going to be saying the coordinate space is the world. And we're going to be doing the same thing for our rotation. So we're going to be taking our spline, and from there, we're going to get rotation at distance along spline. And for the distance, or we're going to make this coordinate space world. And we're going to take our index, and we're going to take our spacing, and we're going to multiply them together. So integer in times float. So we're going to take that and put that as the rotation. So from here, what we can do is just drag that in here. And there we go. Compile that and save that. And that should be it for spawning our coins. So again, just a quick recap. This was the same logic we've taken to spawn our procedural road in terms of determining what the last index is. We're just taking the full length of our spline, seeing how long it is, and seeing the length of each subsection, and see how much of that subsection we can insert into our spline. After doing that, for each iteration in that, we're going to be spawning a coin, and we can do that through this node called spawn BP, called spawn actor from class, and we chose our class to be BP underscore pickup coin. And from there, we needed to supply two arguments, the rotation and the location of our spline, of our pickup coin. And the way we're able to spawn the location, the rotation, is by taking our spline, getting the location along the distance. And from there, we're taking the index and the spacing, and that's going to be our distance. So on the first iteration, the index is 0, so the distance will be 0. But on the next iteration, the index will be 1. So it's going to be one spacing ahead of the first. So if the spacing was 400, the first coin will be 0, but the next coin will be 400. And the one after that, the index will be 2. So 2 times the spacing, which is 400, that will give us a location of 800. And that goes on and on for as long as it hasn't surpassed the last index. So let's test that out. So we have our pickup coin. One thing you'll notice is it's not spawning our first coin, and that isn't really the case. The reason it's not showing up in the view editor is because this code gets executed once we hit our begin play function. So it's only when we click on this begin play that we're able to see our coin. So we can drag this coin in here and spawn. We notice these are the coins. So we'll have our coins, and from here we can just pick them up as such. If you're wanting our BP underscore pickup spawner to have the same functionalities as the ones I showed in the demo, then we can do so by clicking on our pickup spawner. And in the construction script for the pickup spawner, what we can do is have another for loop. And this will be the same for loop we've taken in our begin play function. So if I go into my begin play, I have this spline. So I'm going to be taking that and going into my begin play and pasting that. Have that, and float, divide by float. Nothing new here, just doing the same increment to determine our last iteration for our for loop. And we're going to be truncating that so it's an integer, so it can be treated as an index. And from here, we're going to be promoting this to an index. And we're going to call this index, like how we did in our begin play function, but I'll name this index 2. Since our begin play had just index, I have to name it something else. So from here, what I can do is I can add a static mesh component. And again, just to reiterate, the reason I'm doing this is just so that it has the same functionalities as the thing I've shown in the demo. But this really has no bearing over how it behaves in game, since at the end of the day, you just need the begin play and spawning the actors for your gameplay purposes. But this is just to make it easier or give you a representation of where the coins are going to be before you spawn them in the begin play function. So in here, there was a relative transform. I split that up. So I have location and rotation. And just like what I did with our begin play function, I'm gonna control left click, and I'm gonna take a function called get location at distance along spline. So this will be put for our spline component, so our transform. Okay, so then we're gonna control left click, get our spline, and we're gonna say get rotation, because the second input is the rotation at distance along spline. From here, I can left click and complete the node. So now that I have my location and rotation, I need to figure out their distances, and their distances are based off the current index. So we can distinguish each coin that gets spawned by its index. So if I right click, take this index and multiply it by the spacing, which is 400. So I say index times float. This float. So we have integer times float, and then I'm gonna click on that and just populate that as our distance. And the same thing it's the same logic and it will be the same logic for our rotation. So for our rotation, I'm just gonna drag that in here, and yeah. So if I were to compile this, so move our BP underscore pickup spawner and drag it, we'll notice now, so what we can do is we can see if this for loop is even executing, and we can do so by creating an array. So we're going to be add array, and I'm going to promote this to a variable, and I'm going to call this array coin spawner. for coin collection. So it's just going to contain the collections of our coins that we're spawning in. So I'm going to compile that. And one thing I also want to make sure is, so if I save this, we'll notice right now, I'm going to make this public, the coin collection, compile that. So we'll notice currently there's 17 elements in our coin array, but they're all empty. And then the last 3 is trash. So what we can do to clear those runs out is, the reason it does that is because each construction script, it's adding the coins into the array. So what we're going to do is we just want to save the last run of the construction script. And so we can do that by doing clear and just having it clear before it adds. So that way it only saves it will just save the last run of our construction script. So if we save that, and we'll notice right now there is only 1 element. But if we were to left click, we notice it's creating new elements. But we notice that we aren't spawning any static meshes. So I'm going to choose a cylinder to match our coin. This type of cylinder in here, which is the same mesh as our coin. So if we go into our viewport, we have our mesh. So now it's visible on the screen. So we have that mesh in here. So when we spawn, we notice it's all in one location for some reason. And so if we go back and investigate this, we notice as our index, we used index 1, which was the index we had for our begin play. But for this for loop, we have to pay attention that it's index 2 that's looping. So that would mean instead of index 1, which was used for our begin play, which was used as our for loop for our begin play, we're using index 2, which is the index of our for loop for our construction script. So get that here. If we just save that, we'll notice now it creates our pickup coins, but it's just, we're reminded when we run this, these are just static meshes and not necessarily actors that we can interact with. So we're going to have to, in our begin play, we're going to have to delete these static meshes before we spawn them into the level. And so we can do that by going into our event graph. We can do that in our begin play, by writing a for each loop. And a for each loop will loop through each element. And the element that I'm trying to loop through is our coin collection. So I'm going to control left click coin collection and put that as the array. And as our loop body, all we need this loop to do is destroy the component. So we're going to say destroy component in here. So this will destroy each spline component in each iteration. Once it destroys all the placeholder static meshes that don't really do anything, then once that's completed, and then we can execute the next for loop. So I'm just gonna alt click to get rid of that. And from here, we have our array elements. And so the array element is the thing we're trying to destroy, so that's the target. And yeah, once we've done that, we'll notice we'll notice our coins are here. We'll notice if I were to make the spacing public and save that in the editor, I can modify this to make it more or less as I see fit. So if I were to do 350, then hit play, we'll notice if I interact with it now, it's spawning the actual coins. But then I have some placeholder static mesh that I can use to give me an idea the location and rotation the coins will be spawning in. So yeah, so this concludes the video. If you enjoyed it, please hit like. In the next video, I'm going to be doing this system, but be doing it in C++. So be on the lookout for that.